Alrighty then. 3.5 equations of parallel and perpendicular lines. Equations of parallel, that's the symbol for parallel. That's the symbol for perpendicular. So in a coordinate plane, parallel lines have the same slope and perpendicular lines have slopes that are negative reciprocals. So the book's going to have you do all this stuff. You can write all that stuff, but it's the same thing as this. Parallel, they have the same slope. The book will say perpendicular lines. If you take their slopes and you multiply them together, you get a -1. Yeah, that's true as well. I just do it this way. The slopes, if the slopes are negative reciprocals, that means the lines are perpendicular. If the slopes are the same, that means the lines are parallel. So if they have the same slope, the lines are parallel. If the slopes are negative reciprocals, that means they are perpendicular. Negative reciprocals means slopes are perpendicular. Vertical lines it's an undefined slope. Horizontal line, it's a 0 slope. Please don't say it doesn't have a slope. The slope is 0. Okay. So let's get some practice. Here's two equations for equation A, part A here. We have y equals 2/3 x minus 5, and another equation, y equals 2/3 x plus 6. This is in slope-intercept form. And in slope-intercept form, if you remember, between the equal sign and the x, that is going to be your slope, and what comes after the x, that is going to be your y-intercept. This is your slope, or the m portion, and this is the y equals m plus b, y equals mx plus b. Here's your x. This is your slope, and this is your y-intercept. Oh, yuck, I can't even read that. So this is your slope, so the rise over the run, and this is the y-intercept, where it crosses the y-axis. Okay, so for this stuff, you just have to find their slope. Who cares right now about what the y-intercept is? You're just trying to find out what the slope is. So this slope is 2/3, this slope is 2/3. Are they negative reciprocals of each other? No. Are the same slope? Yes, they're the same slope. So in this case, those two lines are parallel. What about here? That's in slope-intercept form. That's in slope-intercept form. You just check out these. That's your slope, and that's your slope. Are those the same? If those are the same, they're parallel. If they are negative reciprocals of each other, they're perpendicular. Are they parallel? Sorry, are they the same? No. Are they negative reciprocals of each other? No. If you multiply those two together, do you get a -1? No. So it's not parallel, it's not perpendicular. So in the book's going to say it's neither. Neither. Are they parallel, perpendicular, or neither? They're getting a question like that in the book. So here for part C. So there's your slope and there's your slope. Compare the slopes. I don't care about the y-intercepts right now. I just want to look at the slopes. Are they the same? No. So they're not parallel. Are they negative reciprocals of each other? No, no, no. J.J. Watt says no, no, no. If you multiply these together, do you get a -1? No, you get a +1, but you don't get a negative. So this would be neither. It's not parallel, it's not perpendicular, it's neither. Okay. Letter D. Slope-intercept form, slope-intercept form. Here's your root. Are they the same? J.J. Watt says no, no, no. Are they negative reciprocals of each other? Yeah. If you multiply these two slopes, do you get a -1? Yeah. Which means they're perpendicular. Perpendicular. What about E? Is it? There's a slope. There's a slope. Okay. Oh, hey, they're the same, which means they're parallel. Ooh, look at this. These are negative reciprocals. Who cares? It's not a slope. That's your slope. That's your slope. That's a y-intercept. Don't care about that at this point. We're looking at your slope and your slope. Are they the same? No, no, no. Are they negative reciprocals? No, no, no. So they're not parallel, they're not perpendicular. Neither. Okay. Sometimes you're gonna have to find the slope. And sometimes they don't give you an equation, they give you coordinates and you have to find the slope using the formula for slope. So, oops, no, down here. And the doink. Here we go. Question 7. Number 7. I'll get real close in here. Number 7, you have to get really, really close. Number 7. Number 7, get in there. I have to get really in there so it's bright. Okay, question 7. It's already on a coordinate plane, so I'm just going to find the slope using rise over run. Okay, rise over run, it's the difference of your x values, and this is the difference of the x values. Rise, the difference of the vertical and the difference of the horizontal. Okay, rise over run. So for letter A, that line right there, I'll make a little, so it looks like this. So there's a dot there and a dot there. Where is it? There it is. The 2 dots. I can actually put a dot there. So I'm just doing this. I'm just counting that way. I'm counting that. Come on, paper, stop moving. Counting that way and I'm counting this way. So that's 90 degrees. This is my difference in your x values. That's your delta x. This is my difference in the y values. That's my delta y. This character means delta. It's the Greek letter delta. You're going to use that in calculus and pre-calculus. Delta, delta, hurricane delta. Okay, so number 7. We're at number 7. Here's number 7. So I'm making a little triangle just like we did before. What's the difference in the x value? 1, 2, 3, 4, 5, 6. And the y value difference is 2. So for letter A, the rise is 2. The run is 6 units. And that's a positive value. So here, let's quickly go over positive slope, positive slope, positive slope, positive slope, positive slope. These are all positive slopes. That is the slope of 0. That's a negative slope, negative slope, negative slope, negative. These are all negative slopes. Okay? Once you get something like this that goes straight up and down, that slope is undefined. Undefined. And this is a positive slope because it keeps on going. Positive slope, these are all positives. More negative slopes, negative slopes. Okay? So for 7, whoops, whoa, earthquake. Yep, it's the earthquake. So that's a positive slope, positive slope, positive slope. This one's negative. Okay. So A, we just did that for A. A is a rise of 2 and a run of 6. That simplifies to 1/3. Let's do equation B, line B. B, where's B? B is this one, this color. So that distance. So 1, 2, 3, 4, and a rise of 1. So rise of 1, and it's a positive slope. That cannot be simplified. So that's your slope, that's your slope. Letter C is these colors right here. We have this dot, and we have this dot. So you go, so this distance is going to be 1, a 2, a 3, a 4, a 5, a 6. This distance is a 1, a 2. So this is a 2, this is a 6. 2 up, a 6 across. It's a positive slope. Simplifies to 1/3. That's your slope. Letter D. D. So I make my line go. In this case, line looks like this. I have my dot and I have my other dot. So I'm going to go. This is going to be my difference in the y values. This is going to be my difference of my x values. This is your rise, this is your run. Number 7, so we're going to, this is my rise, here's my other dot, this is my run. So we have a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8. And the run is a 1 and a 2. A 2, and we have 8. Is the slope positive or is the slope the negative? Is this slope is the negative? Slope is a negative, and that simplifies to a negative 1 over 4. So this is the slope. Determine which lines are parallel and which are perpendicular. Huh. Well, do any of these have the same slope? I can zoom back out of here again. Get rid of this earthquake moving, well, hopefully a little bit. So it goes from here to there, all right. Okay, do any of these have the same slope? Yes, this one and this one. So line A is parallel to line, that's line C. Are these the same? No, they're not the same. One's positive, one's negative. Wait a minute, this right here, this is not right. This right here, the rise is 4, and that's that's 8, and that's a 2, it's a negative. That's the negative 4. This is the slope. These are not the same slope, but they're negative reciprocals, which means they're perpendicular. B is perpendicular to D. B is perpendicular to D. Okay, for number 7. Sorry for the boo-boo. Number 7. Let's go to number 9. The number 9. Bring it down here. Number 9. Let's go down a little more. There we go. Number 9. Tell whether. Number 9. Tell whether the lines through the given points are parallel, perpendicular, or neither. Neither. Justify your answer. So we have to find a line that goes through those 2 points, a line that goes through those 2 points. Specifically, the slope. The slope. The slope. So 9, so line 1. Line 1. We have 1, 0, and the other line is, the other coordinate is 7, 4. Line 2, 7, 0, and 3, 6. The first line, we need to find the slope. How do we find the c's? If only there was an equation. Use this expression right here. Okay, use that expression right there. M represents slope. So we're going to find the slope, difference of the y values over the difference of your x values. Y values on top, x values on the bottom. Okay, I'm going to call this my x, the first value of x, that's my first value of y, that's my second value of x, and that's my second value of y. So we have, for line 1, the slope is going to say slope. First value of y is a 0 minus second value of y is a 4. First value of x is a 1 minus second value of x is a 7. 0 minus 4 is negative 4. 1 minus 7 is a negative 6. That simplifies to a positive 2 over 3. Line 2. So this is my first value of x is a 7. My first value of y is 0. Second value of x is a 3. Second value of y is a 6. first value of y, 0, minus, second value of y, 6, first value of x, 7, minus, second value of x, 3, 0 minus 6, negative 6, 7 minus 3 is a 4. And that simplifies to a negative 3 over 2. And you have to tell whether the lines are parallel, perpendicular, or neither. Are these slopes the same slope? No, they're not the same slope. So that means they're not parallel. Are they negative reciprocals of each other? Yes, they're negative reciprocals of each other. You can also say, do the slopes, when you multiply these two together, do you get a negative 1? Yes. So that's another way of determining whether lines are perpendicular. So we're going to write for question number 9, line per, oof, that's supposed to be an R, yuck, pep, perpendicular. Justify your answer. There you go. This work justifies your answer because these are negative slope. The slopes are negative reciprocals, or you can say the slopes, when you multiply them, you get a negative 1. So the answer is they're perpendicular. If you want to write it out, you can say because their slopes are negative reciprocals of each other. If you want to write that out extra. Okay. Next one, question 13. Write an equation of a line passing through point P. Here's point P. It goes through 0, negative 1. And passing through point P that is parallel to the given line. Here's your given line. Y equals negative 2x plus 3. Okay. So we have to write an equation of a line that goes through this point and is parallel to this line. Well, that's in slope-intercept form. So right now, we just have to find out a line that's parallel. It says parallel, parallel, parallel. Ooh, parallel. What does parallel mean? Parallel. Parallel lines are in the same slope and they do not intersect. So parallel lines are in the same coordinate plane and they do not intersect. If they have the same slope, they're going to be parallel. So I don't really care about the y-intercept. Here's my slope. Okay, it's going to have that same slope. So we can know, oh, the slope is going to be the same as that one, negative 2. This is the information we need, and we're going to write our equation. Y equals mx plus b. That's your slope-intercept form. The value of this is my x value. This is my y value. This x. This is my x. This is my y. This is my m. So y is negative 2. M is negative 2 times x. Do we know what x is? X is 0 plus b. This is what we have to figure out now. Okay, so solve for b. This times this. This times this is 0. B is negative 2. B is negative 2. M is negative 2. Hey, we can write our equation. What did I do here? Are you kidding me? Y is a negative 1. What am I talking about? Y is a negative 1. So to go through this whole mess again, B is negative 1. So the equation, Y, come on, move up, there we go. Y equals mx plus b. So the equation, our m is a negative 2. Our b is a negative 1. This is our equation. Okay, it's parallel to this line and it goes through that point. There's your answer right there. Let's do another equation. We're going to do something similar. Where are we going to go here? We're going to put it right there. This is number 19. Question 19. point P is 2 comma 3, and y minus 4 equals negative 2x plus 3. I want you to put this in slope-intercept form for question 19. Put your answer in slope-intercept form. Okay, that's not in slope-intercept form. Okay, not point slope, but we want slope-intercept form. So we're gonna. I want you to put it in slope-intercept form. So we're gonna put this into slope-intercept form. That's a negative 2x. That's a negative 6. Now I'm going to add 4 to both sides of this equation. Negative 2x minus 2. Here's your equation. So from point slope, this form, we're changing to slope-intercept form, we get this. Okay? And question 19 states, the instructions state, write an equation of a line passing through this point, P, and is perpendicular to this line. This line. Well, we don't need to worry about anything else. This is your slope. Okay? In point slope form, that is also going to be your slope. Yeah, see, they have the same slope there? Okay, so we know it has to go through this point, and we know the slope is going to be, sorry, hold on. It doesn't say perpendicular. This is a slope, but we want perpendicular. If it's parallel, they're going to have the same slope. If it's perpendicular, the slopes are negative reciprocals. So what's the negative reciprocal of this? So we have to take this, flip it over, and then multiply it by negative. So this, we multiply that by negative, you get a positive 2, and the reciprocal is 1/2. So our new line is going to have a slope of, what did I do with that for? That's a positive 1/2. Okay, so the negative reciprocal of that is going to be a positive 1/2. That is going to be our new slope. So that's our slope. This is our point it goes through. Now we have to write our equation. Y equals mx plus b. I want it in slope-intercept form. So this is my x value, this is my y value, and that is my m. Y value is a 3. M is a 1/2 times x. X is a value of 2 plus b. So this times this is 1. Subtract 1 on both sides of the equation. So we know b is 2. B has a value of 2. So when we write our equation, y equals mx plus b, m, our value of m is going to be 1/2, and b is 2 plus 2. This is our equation. Okay, so write an equation of a line that goes through this point and is perpendicular to this one. So this equation, if you put it in slope-intercept form, you get this. I don't care which version. The slope is negative 2. Okay, we want to write an equation that is perpendicular. So we have to take the slope and find the negative reciprocal. It's 1/2. So now you're going to take this information and find an equation in slope-intercept form. And that's just what you did. Bing, there's your answer. Okay. So then I'm going to go to a little bit more difficult. Let's switch that over. Find the midpoint of line or segment PQ, then write an equation of the line that passes through the midpoint and is perpendicular to segment PQ. This line is called the perpendicular bisector. Ooh, there's a lot of stuff. A lot of stuff in that question right there. P is negative 4, 3, and point Q is 4, negative 1. So First thing, midpoint. If only there was a formula to find a midpoint. I wonder what they would call that formula for the midpoint. What's the formula for the midpoint? Oh, it's the midpoint formula. Back in your notes. So you take your two x values, you add them together, divide by 2. That's my first x value. That's my first y value. That's my second value of x. And that's my second value of y. I'm taking my two x values, add them together and divide by 2. This. So negative 4. And add it to 4. And divide by 2. So my y value, add my y values together. 3 plus a negative 1 divided by 2. So your x value is a 0 and my y value is 1. That's your midpoint. Okay? So the midpoint of, people do this on a coordinate plane, but when you try to do this on a coordinate plane, negative 4 and 4, when people do this, you try to do it on a piece of paper and find the midpoint. See how this is the midpoint? It looks like my midpoint should be right around here. But when you do it algebraically, it's right there. Please don't do this graphically. It's nice and visual, but it's not that accurate. That's why you have the midpoint formula. You do it algebraically. You're going to get the answer correct as long as you know how to use the formula correctly. Okay, so it's going to go through this point right here, 0, negative 1. Sorry, 0, positive 1. So it goes through this point. So find the midpoint, done. Write an equation of a line that passes through this and is perpendicular. So if a line's going perpendicular to this, so if a line's perpendicular to this, it's going to have a slope that is negative reciprocal. So we have to find the slope of this first. Find this slope. How do you find that slope? You use the slope formula. The slope formula we just did. y1 minus y2 over x1 minus x2. Okay, the first value of y, the first value of y is a 3 minus, now what's that? It's just off the page, there we go. So minus y minus the second value of y, second value of y, second value of y is a negative 1. The first value of x is a negative 4 minus, okay, minus the second value of x. The second value of x is 4. 3 plus 1, negative 4 minus 4. That's going to be a 4. That's a negative 8. That's a negative 1/2. Okay, negative 1/2. So this has a slope of negative 1/2. Okay, the slope of this one, this is negative 1 over 2. And the question states, equation of a line passes through the midpoint and is perpendicular. Perpendicular. So perpendicular lines have negative reciprocals for slopes, so we have to find a perpendicular slope of this one. Multiply by negative, and then flip it over. So it's going to be m is a positive 2. Use this information, and we're going to get an equation. Okay, our midpoint, that's our midpoint. So we got that. The slope, we had to find the slope of this one, and it's stated it's going to be perpendicular. So we know perpendicular lines have reciprocals. So perpendicular lines, their slopes are negative reciprocals. So we had to find the slope of that line first, take the negative reciprocal, and that's how we got that. Now we're going to y equals mx plus b. There's a lot of math involved, algebra involved in this one. Okay, y, the value of y is 1. M x is 0 plus b equals 0 plus b. B is 1. Okay, equation y equals mx plus b. Our m and our b. What is our m and what's our b? M is 2. I have m is 2, so put a 2 there. B is 1. Say positive 1. There is your answer. So for question 27, is that all we have to do? This line is called a perpendicular bisector. Pass the midpoint. That's it, we're done. So we found our midpoint, and we found our, did we? Right equation lines. Ooh. So these are too far apart. I'm putting them together. Midpoint is 0, 1. There we go. Put them together so whoever has to read this stuff doesn't have to go searching. Because if I'm doing it, if I see an answer here and there, I'm not wasting my time looking for all your work. Put your answer together so whoever reads it, it just says, I'm looking at one spot. Here's your answer. There's the midpoint, and there's your equation. Well done. Thank you guys. Bye.